Okay, the next topic is constrained motion. And by which we mean that there are some restrictions on motion. Right, so when we say constraint, that word means that basically is a restriction on the motion. What's a restriction on the motion? What's an example of restriction on the motion? So imagine, for instance, we have a wire like so, and we have a particle that moves on the wire. In other words, the particle doesn't move arbitrarily in the plane, but it moves along the wire. And let's say we have x and y, and let's say the equation of this line is so particle let's say the equation of this line is x plus y equals 3. Then let's say the particle moves on x plus y equals 3. Determine the relationship. Well, let me fix this word, moves. Determine the relationship between Vx and Vy of particle, and determine relation between Ax and Ay of particle. What we mean by Vx is just x dot, and what we mean by Vy is just the y dot of the particle, where the particle has position x comma y. Similarly, acceleration is just x double dot. Acceleration in the y direction is just y double dot. Okay, so how would we find the relationship? Well, you take this relationship in position and then differentiate it to get velocity, and then differentiate once more to get acceleration. So solution, this is equation number 1. Differentiate with respect to time. So basically we have d by dt of x plus y equals d by dt of 3. Well, d by dt of x plus y is d by dt of x, which is x dot, d by dt of y, which is y dot, d by dt of 3, which is 0. So that's the relationship that we want, or equivalently Vx plus Vy equals 0, or basically that Vx equals minus Vy. So these are all answers for part A, I suppose. Let's call this part A. Let's call this part B. This is part A. And then for part B, we differentiate once more. And we just get x double dot plus y double dot equals 0, or ax plus ay equals 0. So these are all acceptable relationships for part B. Okay. So that's really what we mean by constrained motion. In this case, it's constrained so that x velocity and the y velocity are actually related by this simple relationship. Okay. What's another example of constrained motion? Another constant example that we will sort of look at over and over again in this course is a simple pulley, or pulleys in general. But I guess as the first example, we will look at a simple pulley. And let's say we have two masses, A and B. What is the relationship? Let's say the velocity of A is VA in this direction. The velocity of B is VB in this direction. What is the relationship between VA and VB? Or if we say this is YA, this is YB, the position of B relative to the center line and the position of A relative to the center line. Equivalently, what is the relation between YA dot and YB dot? Okay, so very quickly, if we look at the pulley, the string that sort of connects A and B has these three parts. This part is YA. This part is basically pi r, where r is the radius of the pulley, and this part is YB. So the total length of string is basically YA plus pi r, which is half the circumference of the pulley, plus YB. That's basically equal to some constant, because we usually assume that the length of these strings do not change, or the string is inextensible, which basically gives this relationship YA plus pi r plus YB equals constant. Because pi r is a constant, because r is a constant, we basically have YA plus YB equals constant, which we can differentiate to get the relationship. This is basically VA plus VB equals 0. Similarly, or VA equals minus VB, which makes sense. Basically, it says that if this object moves down, this object moves up. In other words, VA and VB are negatives of each other. Makes sense. Similarly, AA equals minus AB, so that the acceleration of this object is the negative of the acceleration of this object, and vice versa. Okay, let's stop there.